almost exactly 3 years ago, I was on Hacker News, and I came across Chris McCord's talk on building a Twitter clone using Phoenix Live View. And I'd never used Elixir before and never heard of Live View. But I noticed the comments on Hacker News were really positive, and that was unusual. So I was like, I'll check this thing out. And from pretty much then on, I've been hooked on Elixir and Live View. And so it's really cool that almost exactly 3 years later, I'm speaking at the biggest Elixir conference. And as a side note, that the Twitter clone that I built ended up becoming LinkedIn, which is, well, the way I pitch it is it's LinkedIn, but serious. And so you should check it out, schlinkton.com. This talk, though, is not about LinkedIn. It is about building AI apps with Elixir. As you may have heard, AI is really hot right now. But what I want to talk about is Elixir in AI, because everyone's talking about AI, but not enough people are talking about the ways you can use Elixir in AI. My name is Charlie Holtz, and I'm a hacker in residence at Replicate. And Replicate is a startup that makes it really easy to run machine learning models using an API, and it runs in the cloud. I'll get more into what Replicate does later. But I'm a hacker in residence there, which basically means I build stuff with AI and then talk about it. And that actually is my official title, hacker in residence. When I was joining Replicate, the CEO asked me to give myself any title I wanted. So I said, OK, I'm CEO. And then he said, OK, you have to pick something else. And I went with hacker in residence. And so that's what we stuck with. And I built dozens of AI apps now. Where I define AI apps, where any app where the core logic uses AI of some kind. And I try and build as many as I can with Phoenix and Live View and Elixir. So this talk is about 3 patterns that I've noticed come up again and again as I'm building these apps. And I want to give you these patterns as a way to get started building AI apps yourself. And I think it's going to make you a lot faster at building AI apps, and I also hope it will inspire you with all the cool things you can build yourself. And the 3 patterns are called the Magic AI Box, the Gen Server Generator, and Agents. So we will start with the Magic AI Box. The way I've been thinking about AI is I'm not worrying about how it works or how to be a machine learning engineer or any of that. That's for other people to figure out. I want to think about all the ways I can use AI. And so I like to imagine AI as this magical box that I can put an input into, and it does something really cool with that input and give me the output. For example, in this case, I put in the text input, a cat with a hat. It goes to our Magic AI box, which we can think of as a module or a function or an API. In this case, we have Stable Diffusion inside that Magic AI box, which, if you haven't heard of it, it's like Midjourney or DALL-E. It's a text-to-image model. So we put in a cat with a hat into our Magic AI box, and we get out a cool-looking cat with a hat. We'd also put GPT-4 inside this box, which I'm sure you've heard of, a text model from OpenAI. And in this case, we put in a cat with a hat, and we get a feline wearing a head covering. We could also put in a text-to-video model. These are pretty new right now and very primitive compared to the other models, but it's pretty amazing to me that you can put in text to this model, and then you get out something that looks like, I'll play the video, a 2-second video of cats sort of wearing hats. It's close enough. The point is, you can put in all kinds of things into this magical AI box, get all kinds of outputs back. You can get images, you can get text, you can get video, you can get audio, you can even get QR codes, which I'll show you at the end. And you can go really far with just this simple-looking pattern. So a simple input Magic AI box pattern. And it's not to say that this pattern isn't difficult to build apps with. It's just a simple mental model. And if you've heard of Peter Levels, he's making over $100,000 a month with his apps Photo AI and Interior AI, which essentially you put in an input image and then does a bunch of upscaling and cool things to your image. It gives you a better result. So the point is not that it's easy to build these things, but it is a really simple pattern. You can also think of ChatGPT as following this pattern. You put in a text, does something magical with that text, and gives you text back as a response. And as a side note, he is using Replicate to run his apps, which is cool. The way this looks in Elixir is actually just like what Chris was talking about, using the task async library. So in this case, let's say we have a form that you type in a prompt. We listen for that prompt in our handle event, set up a task async call to our, let's say, our magic box model. Then we handle the info, exactly how Chris was showing us, update our prediction, and then stream in the results. So let me show you very quickly what this looks like. Let me spin this up. So here we have essentially a boilerplate Phoenix Live View project with a form component here and a generate button. And what's going to happen is when I type in enter, we have a listener in our index live view file that's going to listen for the prediction, run the task.async request on generate image, which all it does is it takes in the prompt and uses, in this case, replicate to run Stable Diffusion on that prompt. We're going to handle the info callback here, update the prediction, and then insert it. So it looks something like this. Let's say I say cat, press enter, and we can do something else now while it's loading. The task is going to run. It usually takes a few seconds. In this case, we're running Stable Diffusion, and here we have our cat. And I think this is like actually really amazing. The fact that there's an Elixir primitive just called task.async that lets us run Stable Diffusion, and it takes 2 seconds, it takes 10 seconds, and we can do other things while that's running. That is not built into other languages. I know I'm preaching to the choir here, but I've had to build similar things in React or in Python, and it's a lot more work. And I think it's really cool how few lines I can run an asynchronous call. I also think it's cool that I can type in a bunch of things all at once, and they're going to now async in the background, render or load, and then render with the associated prompt. I'll give that a second to run. Okay, see, we got our turtle, match up with turtle, cat, so on. So that's basically the simplest possible AI app. But you can go, again, you can go really far with just this magic AI box pattern. The second pattern I want to talk about is what I call the gen server generator. So is anyone here either a pilot or an aspiring pilot? You can raise your hand. Okay. Okay, there's some people. So do you know what a METAR is? What's a METAR? Exactly. Okay, so a METAR is in the aviation world, it is a way of talking about the weather in this kind of inscrutable looking code that looks like this. So this is the Orlando weather last night as I was coming in. I didn't fly myself. I just looked this up. And it's really hard to understand, especially if you are not a pilot. And even if you are a student pilot like me, it takes a lot of work to understand what this is even talking about. So I built an app for myself called METAR Quiz. And the way it works is it shows me a METAR, which is in the gray box, and then it asks me a question about that METAR. And there are a bunch of ways I could have populated the data for this quiz. I can actually show you. There's a database of about over 1,000 questions, where here I have on the left the METAR, and then on the right a question I have for that METAR. And so there were a few ways I could have populated that data. I could have done it by hand. I could have written a bunch of METARs by hand. I could have maybe found a weather API and pulled the METARs from there. But that would be tedious and not that fun. So what I decided to do is I used GPT-4 in this case to generate a METAR from scratch and then also generate a question about that METAR. And so this gen server generator pattern works really well whenever you want to build something that has a bunch of cached data that you then want to reference. And it builds that cached data using AI. So in this case, the pattern looks like this, where we have a gen server that calls our magical AI box, which then saves the output to a database, and then we can render it. So up close, and again, I don't necessarily want you to worry about the code line by line. I just want you to get the gist of what this looks like. And I also will have all the code available open source after to show you. But the general idea, step by step, is we have a gen server, which in this case is sending a request to itself every 5 seconds. And in our handle info function, you can see if the count of the questions is under 1,000, then we will create a new question with AI. And so then we go to our magical AI box. And our create question with AI is actually mostly text. And this is another thing that I've noticed come up over and over working with AI apps, is that you'll have functions where most of the lines is text, is plain text. And this is really cool because plain text is really easy to read, and it's really easy to edit. There are downsides to having functions like this, but I think it's mostly benefits. And so in this case, our create question with AI function looks like a request. We can see on the top it says the model is GPT-4. Then you are a helpful bot that helps users learn about aviation METARs. You create quizzes, create a new quiz, have one question in the JSON format. And then I give it a few other instructions, and then we'll get a question that we can then put in our database. As a side note, when I put this out in the r/flying subreddit, I would continually get feedback. It asked a question, BR actually doesn't mean light rain, it means mist, and a lot of feedback that I could then just add to this, this text field directly, just so you know BR means mist, not rain. And then after that, it started working again. So I could edit the code just by editing the plain text. I think that's really cool. Then the next step in our pattern is we save to the DB, which is really just decoding and then creating the question in Ecto. And then we render it in live view. So the pattern is again, it's quite straightforward, but really powerful. And I think it gets a step more powerful when you add what I call the interactive sprinkle. And what this means, I think this is best explained with a quick demo. And before I show you the demo, every time I type in a response to the METAR question, in this case, I need some way of verifying whether the question was correct. So for example, in this case, we show a METAR for Pittsfield Airport, and it is asking a question, wind speed, question mark. And in this case, the wind speed is shown here. It is 0 knots. So there are a bunch of ways a user can answer the wind speed in this METAR. You could say 0 knots, which would be correct. You could say 0 kT, which would be correct. You could say 0 miles an hour. You could say no wind. But as a solo developer working on something like this on the side, it's kind of difficult, or it's an interesting problem how you parse the user's input and decide whether it's correct or not. You could maybe make it multiple choice and have like C be the correct answer, and then in your backend logic, if the correct answer matches up, then you know the answer is correct. There are lots of ways you could solve this, but I decided to use GPT 3.5, which is another one of OpenAI models, and it's much faster than GPT-4 and much cheaper. So what happens is when a user enters an answer, in this case they say 0 kT, it marks it as correct. In this case the user says no wind, which is marked as correct. You could say very calm, which I would say is on the cusp, but it still says it's correct, and 0 miles an hour, and all those answers are correct. And I think this makes a really nice user experience because the answer to the question is not so brittle. It's actually dynamic. It feels like there's a human on the other side that is determining whether your answer is correct or not. And the function that determines whether we're correct or not is, again, mostly text. I call it check answer, and I tell GPT 3.5 Turbo, you're a helpful bot that helps the users learn about METARs. The following question was asked about this METAR. The user answered this. Are they correct? Answer in the format true/false, semicolon, semicolon, explanation. And the reason I use this semicolon, semicolon syntax is so that when the answer is spit out from GPT, I can split on those two semicolons and then render in the live view. This was true, and this is why it was true. So again, we have a function that's mostly text, and really easy to edit. If it starts giving true answers when it shouldn't be, I can give it more examples, and it might fix it. And it's really easy to understand what's happening here. Also, as a side note, I'm using a sigil that I made up, ~x, which maybe during the question times I will go into, but it's a nicer way to write prompts to language models. So again, we have this GenServer generator model, which can create data for us using AI, but then this interactive sprinkle, which I think is actually a really magical thing that AI has granted us, the AI gods have granted us, because as a solo developer, that specific example would have been really hard to build. But there are lots of other cool ways you can use the interactive sprinkle. Like I've made a tic-tac-toe game where you bid on each square, and I realized that I could translate the tic-tac-toe game into text, into like a JSON board, and then send it to GPT, and then use GPT as an AI to play against. You could also do interactive stories and all kinds of things with the sprinkle. Third pattern I want to talk about, I call agents. If you're in the AI world at all, you've probably heard of what people are calling generative agents. A few months ago, a paper came out of Stanford called Generative Agents, and it's a really crazy paper. Basically, what the researchers did is they made it's kind of like a version of The Sims, where each character in the Sims world has a large language model serving as their brain. And they are different characters in this world with specific memories and specific personalities, and then they can interact with each other in real time. And it's like kind of this bizarro video game world that feels alive because each character has their own memories and feels very human. So in this case, we have one AI agent going to a cafe and talking with another AI agent, and in the bottom right for you, the AI agent sharing news with colleagues. And what's crazy is that they'll converse and then have a memory of that conversation, and it's all generated in real time. And so as I was reading this paper and thinking about what this means a few months ago, I realized there's really three things, or there are a bunch of things, but there are three primary things that you would need to implement this yourself. So you would need real-time updates. You would need some kind of memory for the agents. And you would need a moderator, which is either an agent themselves or like a super moderator, like a God mode type thing that decides who speaks next and the state of the world and so on. And so these three things are actually Elixir primitives. We have pub/sub built into Elixir, which allows for real-time updates and for broadcasting and subscribing to things. We have memory, or we have state, which is many languages have, but Elixir has it too. And we have supervisors, which we can use as our moderators. And if you look at the Elixir docs talking about GenServers, we have a GenServer as a process like any other Elixir process. It can be used to keep state, execute code asynchronously, which we need for our AI models, and it will also fit into a supervision tree. We even have something called an agent in Elixir, which is simplification, or it's an abstraction around GenServer that allows state to be retrieved and updated via simple AI. So I was reading this, and I was like, AI agents are really hot right now. And there's a thing in Elixir called an agent that happens to have all the things you need to make a generative agent. And the way I've been thinking about this pattern is I have a supervisor which manages individual AI agents, which are GenServers or Elixir agents. that make calls to their own little AI magic box, which serves as their brain. And if you zoom in on an agent, they kind of have four functions that, or four like domains that they need to each keep track of. So each function needs a generative AI function, which makes requests to either OpenAI or Replicate or some other service, which it can use to make decisions about what to do and how to respond to other agents. It needs a subscribe, which are kind of like I think of as like the eyes and ears of the agent, because as things are happening in the world, they get broadcast, and then the agent can listen and sense those things and then respond to them in real time. They have a broadcast, which lines up with our subscribe, which is you think of as the voice of the agent. And then they also have just ecto, which is you can think of as like the hippocampus of the agent. It's the memories, because every time something happens, it will be saved into ecto, and it can then refer to them. So I told you briefly about LinkedIn. I also own Shinstagram.com, and I thought this would be a perfect place to put a bunch of generative AI agents inside of and have them post pictures and respond to each other. So I'm going to show you a quick demo of what the agent model looks like. So inside our Shinstagram Live View app, I'll make this a little bigger so you can see it. Inside the application, we're starting all our children, and here we start the AI stuff. And so we have a profile supervisor, which, again, don't necessarily want you to worry line by line about what's happening. The point is to get the gist of the functions in the file. So our profile supervisor starts up a profile, and then inside our agents, our profile agents module, we have an initiation state, which when an agent is initiated, it subscribes to our channel, which in this case is the feed. It broadcasts a thought, and then it sends a message to itself to think, which you can think of as a callback that is the mind of the profile. And inside our think step, we decide our next action, broadcast the thought about that action, and then send a message to itself to carry out that action. So like our next action calls our action probabilities, which in this case is a profile can either post, look at a profile, or sleep. And then it can, the decisions can branch out from there. And these little numbers after each atom are how much that agent wants to do that particular action. So I've hard-coded it to preferring posting 70% of the time, preferring looking 20% of the time. And I think the look function is interesting because the agent broadcasts that it's scrolling this feed, decides a random number of posts to look at, and then for each post, it evaluates that post, which again is a function that is mostly text, where I describe the context of the situation. In this moment, you're looking at a post. What do you want to do? What does your profile choose to do? Let me show you what it looks like, because I think it's kind of interesting to see live. Let me make sure I shut this down. Okay. So this is what Shinstagram looks like. On the left here, we have a feed, like regular Instagram, where each photo is generated by AI by a AI-generated profile. So in this case, this is a zebra lover. You can see that zebra lover loves zebras, which seems obvious based on the username. And I give it what I call a vibe, which is the kind of images that it likes to post. So in this case, this profile likes posting oil paintings of zebras, which checks out given the images they're posting. So I think it could be cool to make a profile live. And I think it would be fun to make a profile for Jose. So let's name. For images, let's look up let's get image from Twitter, copy image address. You can just be Jose. I created, is Jose here? What kind of photos do you want to post? What do you want your vibe to be? I can pick one for you if you don't, yeah.
I'm a positive person.
Positive person, okay. Positive vibes. Let's say paintings of cats. Okay. So we've created our, oh, I spelled your name wrong, sorry. Save the profile. Okay, so there's a button here that says wake up. And when I click that button, it's, the profile supervisor is going to start up the Jose agent and assign it a process ID. And then we should see live what Jose is thinking. So we can see that Jose is now awake with an associated process ID. And his first thought was, I'm waking up, okay? And then shortly after, he decided he wanted to post. He then picked a photo subject. Then he took a photo of a close-up painting of a gleaming black cat, and then posted the post. This is your first post on Shinstagram. Intergalactic whiskers. Converging the mysteries of galaxies and the mystique of a cat's gaze in a vibrant color palette for an infusion of positivity. So you're both positive and you like cats, so that worked well. And then you just post it again. We can then post sleep, or we can click sleep, and then it's going to send a message to the Gen server to go back to sleep, and we can see you're now asleep. And I think where it gets even cooler than this is if I click this button, which is wake up everybody. And what this is going to do is do the same thing that we just saw, but it will do it for all the profiles on Shinstagram. And so it's going to quickly get a little bit crazy. So I'm just going to click this button. Suddenly, all our profiles are coming online. We can see that they all now have these. Each one is associated different process ID, which makes sense. Byte Dreamer is scrolling the feed. Dreamy Digits is evaluating a post. I Love Zebras just posted. What's interesting now, oh, Jose just posted again. What's interesting also is that as the images are being posted, the other AI agents are seeing it and reacting live. So I'm sure we'll start to see comments and likes streaming in. If we then click on, let's say we click on Jose, we can see exactly what he's doing. So we can see he posted this post. I hope it goes well. It looks like he's taking another photo. I want to find an example of someone evaluate. Okay, so we can see here that Cosmos Coder posted 30 seconds ago, and also SRC Dreamy Digits liked it. So we can actually click on Dreamy Digits and see his exact reasoning for why he liked it. So we can see he was evaluating the post, and then here, I want to like post because I'm captivated by the mesmerizing neon binary rain. And let's click on the post. Yeah, that is cool, binary rain. So I think you get the idea. These are all really Gen servers at their core. They're using Elixir primitives. This is all happening live. They're using a mixture of AI models like Stable Diffusion and GPT. And drenched in color, this captures beautifully the transcendent code of feline energy. Your perspective is inspiring, Jose. Very nice, very nice. So I'm going to shut that down now before it takes over the world. To close things out, a couple of things to think about is, the first is what should you put in this magic AI box? And these are two dependencies I now always add to my Phoenix projects. I add OpenAI and I add Replicate. I actually wrote the Replicate client, so I'm a fan of it. You can use thousands of open source models using the Replicate client. Here's a few examples from our site. These are just happen to be ones we're featuring, but we have a coding generator, CodeLlama, which came out from Meta recently. We have Stable Diffusion. We have Music Gen, which lets you generate music. We have ZeroScope, which can generate videos. All kinds of things. There's so many opportunities and so many cool things you can build with these models right now. And it happens to be that Elixir is really good at doing that. So just to repeat again, we have these 3 patterns: the Magic AI Box, the Gen Server generator for generating data with an interactive sprinkle, and we have agents. Elixir primitives are great for AI, so hopefully this gets more people talking about the ways you can use Elixir and AI. And I think as Elixir developers, and LiveView developers too, it's a really, we're really lucky in that all our primitives happen to line up well with this AI world. This is a QR code I generated. If you scan it, you can get $100 in free credits on Replicate. But I hope you enjoyed this. I hope it inspires you to build cool AI projects yourself, and happy to answer any questions.